So today's job is to teach you how to get this number when you're doing a problem like this. Let's see. Nope, not squared, sorry, 4x. How do you get this number? That's what I'm going to teach you today. For right now, would you just see if 2 actually is a factor? Actually, we'd call it a root. Is 2 a root, or is 2 a 0 for this? Well, you go 2, 1, -4, -5, draw the line. This is called synthetic division. You just learned it yesterday. All right, in case you're having trouble figuring out how to start, you just always drop that first number down. And then you multiply. 1 times 2 is 2. Then you add, -2. Then you multiply, -4. And did those two make 0? No. So what they did make was -9, and that's important because if you're proving that it's not a factor, you have to have that number as your proof. You unplugged it? Thank you. So that's your remainder, and that proves that 2 was not a 0 or a root or a solution. All right, so let's do one where it actually can work. You can practice this skill you learned yesterday. And I'm going to put this numbers above it. X to the third minus 3x squared plus 5x minus 15. Now, I'd like you to do it this way. There's more than one way to factor this, but I'd like you to do it with synthetic. I taught you yesterday. You're probably not good at it yet. It's the secret to at least half of the hardest problems are synthetic division kind of questions. So you got to be good at this. One, -3, 5, -15. Draw a line, drop it like it's hot. How many of you are done already? Raise your hand if you are. Awesome. Adra, did you get a 0 at the end?
Yeah.
Awesome. So you got a remainder of 0, so you can tell it worked. All right. Now, please also include the actual answer, which is like got 2 sets of parentheses, you know? And it's your answer after it's factored. X minus 3 up in the front. And since I'm going to make the constant yellow here, then that means this is the x's and this is the x squareds. And just put pluses in there if there's no other sign. And now I got x minus 3 and x squared plus 5. How many of you were able to do that? Okay, good. That's called synthetic division. It's kind of a big deal. All right, now what's the actual solutions? Well, x equals 3 is an easy one. That's a solution. Caitlin, how do I get the solutions for this?
You take the square roots of
Yep, but tell me how to get there first. X squared plus 5.
x squared plus 5 equals 0.
Good, then what?
You take the 5 over, so add, subtract 5.
I agree, and then we square root it like you were saying, and then absolute value of x equals, what's this next part?
It would be absolute, positive or negative, I square root 5.
I square root 5 is correct, but don't put the plus or minus there. Here's why. What you're trying to do is say this is equal to this, and it is. It is not plus and minus yet. The reason it's not plus or minus is that comes from this. The split is where you get the plus and the minus from. See, the absolute value is still containing the x. To get the x out of that, you need to make separate equations. I root 5, negative I root 5. All right, cool. So those are two imaginary solutions. Are they x-intercepts? No, if it's imaginary, it's not an x-intercept. Are they solutions? Yeah. 2 plus 1 makes 3, and look, it was to the third. It should tell you there's got to be 3 answers, and the smart kids take a second to check that, because if you get a list and you only have 2 solutions and you look up and you're like, oh crap, there's got to be 3 solutions. All right, next. There can be such a thing as a double solution, though. Let's talk about that. We haven't done one of these in a while. What are the 3 solutions here? Let's say that's at 4. And let's say this is at 7. That's where it's hitting it here and here. And this one's at 0, 0. One of these solutions is a triple root. One of them is a double and one of them is a single. Could you write the equation that goes with this? Hint, like there's a 4 there, so then one of your parentheses will have an x minus 4. It's something like that. Okay, see if you can finish this off. It's really important that you can go, oh, I see why we're factoring. It's because then I can know what the graph looks like. That is why we're factoring. So we can tell the x-intercepts. All right, another part of this answer has to do with the 7. And another part has to do with the 0. Now, you could have 2 choices. You can say x plus 0, or you could just say x, because x plus 0 is the same thing as x. And then since that one's a triple, it'd be to the third. This one's a bounce. That's a double root. It's like there's 2 answers of 4. And then this one's a single. I could put a 1 there, but I don't have to. If I don't put a 1 there, it'll be assumed. And then who remembered that it was down on the right and therefore negative in front? Who caught that? That was only like 8 people. That's going to burn you on the test. Watch out for it. They say a good teacher knows where the kids are likely to make their mistakes and tells them about it. So you've been warned. It was going down on the right. You have to have a negative in front. Then I said, I notice on a lot of papers of kids who get the straight A's is they'll have a little y equals negative x to the 6th on the top of their paper, and then the y-intercept. And the y-intercept is where x is 0, and if I put in a 0 here, the whole thing becomes 0, so then there must be a 0 as a y-intercept. Now, why do really smart kids do that? Because it helps them check it. Because, see, this is even, and that means both ends should be down, and they are down, and I can double check that, see? And this is negative, which means it's down on the right. And if you were in the process of checking it, maybe that would be the moment where you'd go, oh, crap. This one's down on the right, and I don't have a negative there. And then last but not least, the 0 y-intercept. Yep, I have a y-intercept at 0. That makes sense. So having this extra little thing, not required, but very smart. Okay, so with that lead up, I have one more factoring problem that I think we should do, because this gets a lot of people. Factor this one. I'm not going to have you do the synthetic kind of factoring on this, because I'm not going to tell you what the root is. I'm just going to say factor this. This will be the hardest factoring test that you'll ever take. There's two kinds of kids right now. The kids who noticed that there's a 2 in everything, and the kids who didn't. If you are one of the ones that didn't notice that, take a second and use that info. That's your first step. Now, I just realized I messed up on this question because that's it. That's as far as you can factor it. If you thought you could factor further, I get trying, but unless you can prove it to me, did anybody find one they think factors this? Because I don't think it factors. All right, so can anybody guess where I made a simple sign mistake? And if I change the one sign, it'll factor. Yes? If it was a -4. And so we're going to do that. That's an oops on my part. This should have been a -8, which would then mean that this is a -4. And now it will factor a lot further. Hint. So I know you know that it factors to x squared and x squared. I hope you did the signs next and realized, ooh, it's a negative at the end. So it must be a plus and a minus. And then you probably figured out that it isn't a 2 and a 2 or you'd never get a 3 in the middle. So it must be a 4 and a 1. And this plus 4 and minus 1. But who sees the catch? Apparently you would have all got it wrong. Adria. That's a good guess, but it cannot factor. That's a good guess. If it had been x squared minus 4, it would have been able to factor. Good try, though. You're on the right track. There it is. Yes, and so many kids forget that one. I think everybody in the room just forgot that one, except for Bennett. If you're like, I don't understand how it factors, well, just follow the little rules. Start with an x and an x. The last number's negative, so then it's a plus and a minus. It'll lead you down the path. What multiplies to 1? 1 and 1. And it actually works. Okay. Now, here's my question. If you looked at this and said, I got one answer for this, one answer for this, and one answer for that, I got 3 answers, what would tell you that that's wrong? Yeah. This 2 does not give you an extra answer if you mean that 2. If you mean that this is squared, then yeah, that would tell you that that's wrong. And here's another way you can know it's wrong. It's supposed to have 4 answers. See that 4 at the top? That tells me that there's supposed to be 4 answers. I'm only getting 1, 2, 3. Oh, that's right. The x squared plus 4 gets you 2 imaginary answers. Take a second, solve that, figure out what those imaginary answers are. Hint, set it equals 0. You've been tested on this twice. You're supposed to know how to solve it. See, that's one of the challenges to this test, is it makes you remember all the stuff you did on the complex numbers test. If you wanted an easy math class, there is one. And I'm serious right now. For some of you, it's a real life option at the semester where you can switch to regular. Totally works. And your life will become a walk in the park when it comes to math. I hope that you don't want to be that bored. But if you, I don't know, maybe at night you're spending 2 hours a night in this class and it's just too much. Well then, you can switch to regular at the semester. Totally okay. You still have a semester of honors on your credit, and you just go to regular and probably get a straight A without having to really work too hard at it. But I hope you like the challenge. Absolute value of x and 2i. And if you put the plus minus in right there, you're wrong, because this does not have two answers. It has only one answer. The reason there's two answers is the absolute value split. And I think I'm going to start teaching this next time as copy it exactly twice. So that, because people get confused on how to make the two equations. Make it exactly the same. And then just throw in one negative right there. That's it. That's the only difference. All right, so then my answers are 2i and negative 2i, and they're imaginary. Can they be x-intercepts? No. So when they ask for what are the x-intercepts, don't include them. Would these guys be able to make x-intercepts? Yes. So there's 4 answers. We know there's 4 answers because of that, but only 2 of them are x-intercepts. All right, I feel like you're getting it. And now, don't write this down, just look. If I give you a problem like this, synthetic division, where was I getting this from? It was always given to you in the problem. It would say, like, assume that 2 is a factor, or that 2 is a solution, or 2 is a root. They always give you the 2 part. Well, how do you get that part? So I'm going to show you with one problem that we did earlier. Don't write this down. Just look for a second. We did this problem already this hour. And I told you that 3 would work. And again, up until now, you never had to figure out that number. But now, we're going to include a question on the test that is this hard. And in fact, harder. It'll have one more term. It won't just have 4 terms. We'll go up to 5 terms. Okay, so it might like lead with a plus x to the 4th or something. So it's got 5 terms, and you got to factor it. And that means you got to figure out what number goes here. So to figure out what number goes there, all you can do is get a list of things that might work. And you get that from a little formula. Now, if you got a really good memory, you might know what number actually did work on this red equation that we did earlier today. Anybody remember what number went into that? 3 was right. Good job. You win for memory for the day. Now, 3, is it true that 3 was a factor of 15? Yes. Now, did every factor of 15 work? No. Only one of them worked. But what you do to get your list, and this is a typical test question, it's also your typical homework question for today. Give me a list of things that could work. And then from there, you just got to try them and see if they work. So here would be the answer for this question. What things could work? Now, this is the part where I'd like you to copy this problem and write F con over F co. This is a little formula for figuring out, it's called the rational root theorem. And the rational root theorem is really long, and you're not going to want to memorize it. But you should memorize F con over F co, because that sums up the rational root theorem. Now, what do you, just take a question, like take a logical guess, given what I've been talking about and saying 5,000 times since we started this unit, what do you think the F stands for? Function's a good guess, that's reasonable. What's the other word I've said more than that even? Factors. The factors of the con. Take a guess what that stands for. Come on, there's a con word in here. Yes, the constant. That stands for factors of the constant. And then when you have a fraction bar, that means divided by. And you actually have to divide it by something. And given that I said this stood for factors, that also stands for factors. And what do you think co stands for? The coefficient. And there's only one really important coefficient. Which one is it? The lead one. So if I wanted to tell you all of this and make the equations sound super complicated, I would say find all of the factors of the constant and then divide them each individually by all the factors of the lead coefficient. But I think it's a lot easier to say F con over F co. What are the factors of the constant? Well, 15, it's got a bunch of factors. It's got 3 and 5 and 1 and 15. I don't have any rule that on the test that they have to be in order from small to big, but on the Schoology quiz today, you have to put them in order from small to big, because otherwise there's an endless number of permutations for the teacher to type in as right answers. So you got to put them in order from small to big. And one more thing that doubles how much work you have to do. You can't tell if it's going to be positive 3 or negative 3, or positive 5 or negative 5. And so what you do is you put a plus minus in front of all that. Now, I said that you'd have to divide by the factors of the coefficient, but the coefficient's a 1, and there's only one factor of 1, and that's a 1, and do you really think I want you to divide them all by 1? That's not going to, it's just be a waste of time. They're all going to stay the same, right? So in this problem, here are the answers that you would have put into Schoology for what were the possible factors. And you have to put them in order from smallest to biggest. So what would be the smallest of them all? Nope, there's something smaller.
Negative 15.
There it is. Negative 15 would be the smallest of them all. And what would be the next smallest? Negative 5, and then what's the next smallest? Negative 3, and then what's the next smallest? Negative 1, and then what's the next one? 1, and then 3, and then 5, and then 15. Now, that's a ridiculous number of things to check. We won't have any that are that long on the test, but I could totally see there being 6 things that you'd have to check. Maybe even 8, but there would never be this many. All right, so how would you check them then? Well, we already know that 3 worked because I told you. 3 works on this one. But you literally, and we're going to do this in a minute, you would literally just check them, and I'll show you how to check them incredibly fast. Some kids get insanely fast at this. So I write out my little box, and then I put in the number I want to check. Like I already checked 3, and I know that works, so I'll try like 1. All right? And then I go 1, negative 3, 5, negative 15. And on your iPad, as you're doing your homework, you can use the back key. So you try it, you try like 1 and then you see if it works. And you can then hit the back arrow when it doesn't work. So I'll show you how fast you can check it. Drop it like it's hot. 1 times 1 is 1. Add them, negative 2. Multiply them, negative 2. Add them, 3. 3 times 1 is 3, and it didn't work, see? Because I didn't get 0 at the end. So now I can hit the back arrow a bunch of times. And then try 3 and see if it works. Or try negative 3 and see if it works. And it's kind of a pain. It's probably the most tedious thing that we ask honors higher algebra students to do. But that's because there is no math rule that will tell you which of these works. There's the only thing that's close is this theorem called the rational root theorem, which tells you a list of the possible things that will work. One of those will work, but you can't tell which one will until you try it. All right, I think you got the idea. And that's it. We've made it to the end. Now we get to the Schoology quiz. Everybody find the homework, and we'll start it together. It is a Schoology quiz. We would have a little bit more work time today, but Mr. Erickson had to squeeze in that survey somewhere, so. And I do understand why he wants to do that. If you really honestly want kids' opinions on what could make the school better, you have to ask them, and you can't personally interview all the students. There's 3,300 of them, right? And then if you're gonna ask them to do a survey, about 0% of people would do it at home. And if you do it at home, it might be because you're really angry at the school and you're gonna therefore give a biased response. Or because you really love the school and you're gonna give a biased response. And so if you really wanna get a lot of people to do it, you gotta do it at school. And so yeah, I understand why he needed to ask for that today. So, and I hope you gave him good, honest feedback. All right, here we go. Number 1 of the Schoology quiz. Andrew, would you read it, please? Just read the equation.
All right. Y equals x to the third.
Yep.
Minus 3x to the fourth.
Yep.
Plus x to the third. Yep. Plus 2x squared.
Yep.
Plus 3.
Thank you. Now we got to do FCon over FCO. And I would have a piece of virtual scratch paper open. And in this case, the factors of the coefficient is just a 1. Dividing by 1 is not going to really do anything, so I'm going to kind of skip over that part. What are the factors of the constant? Well, that's the constant. There's not that many factors of 3. It's 1 or 3, and I'm making a classic mistake right now. What'd I forget? The pluses and the minuses. Yes, the negative aspect. So now, since you have to list these in order from smallest to biggest, what is the smallest possible thing that would work? -3. And what's the next one? -1 and then 1 and then
3.
there you go. Now, the next question, number 2, they give you the same problem, except this time they say which one actually works. So you got to go off and try -3 with 1, -3, 1, 2, 3. Draw the line, and you see if it works. And like a pro tip I gave you was, if it didn't work, just hit back arrow a bunch of times. Try one of the other ones. If that doesn't work, the way you can tell it works is if you end with a 0. If you get a 0 remainder, you found it. And then you actually have to factor it again. All right, so I want to give you a minute. Everybody work on trying to find, was it -3? Was it 1? Was it -1, or was it regular 3? Let's save some time. Somebody's found it by now. What worked? 3 worked? Okay. Bennett's voting for 3. I will trust him, and I will do 3, and you should too. Drop it like it's hot. 0, multiply 0, add them as 1. 1 times 3 is 3. 3 times 2 is 6. Oh, I'm afraid it's not working, or I screwed up, which is very possible. Double checking. Okay. All right. 3 didn't work. Who's got one that worked? Hitting back arrow a bunch of times. Well, I'm going to try -3. You guys try something else. Somebody will find it. Yeah, that's not going to work. I can tell -3 is not going to work. Must be 1 or -1. I'm going to try 1. Is there any chance that I copied the numbers down wrong? I don't think so. Uh-oh. Uh-oh. Did I copy this problem correctly? Did it have an x squared and then did it not have any x to the ones?
There's an extra one. That's
Okay, this is our first problem like this. That's why it's not working.
-1 works, I think.
So even if it did work, it would be working for the wrong reason. Because, watch this and pay attention to this. This is the last thing I thought it was going to be covered tomorrow, but it's today, I guess. The last more complicated thing is when you're doing one of these, which is called synthetic division, if there's ever a missing term, you have to put a 0 in for it. They didn't have any x to the ones, so I have to erase this and put there's 0x to the firsts plus there's a 3. See, it's a placeholder. And that means,
Anchor time is now starting.
okay, and that means that at the end here, there's a 0 that sneaks into my equation. 0 and then 3. And now something is going to work. We still have our correct list. These are our correct list of things that could work. All right. So now I'm going to check 1. 1 times 1 is 1, and this will be -2, and this will be -2, and then add them and I get -1, and then it's multiply them as -1, and add them I get 1. 1 times 1 is 1. 1. Rats.
For anchor time.
All right, can you show me a pass? I'll happily let you go. I do get that some of you have been requested for anchor time somewhere else. If that's the case, show me a pass. I'll happily let you leave. I want to pause for a second here. Somebody said that a -2 works. Did I hear that right? Oh, -1 works. Thank you. Okay, so drop the 1 like it's hot. Multiply -1. Add them -4. Multiply them is 4. Add them is 5. 5 -5. Add them is 3. 3 times -1 is -3. Add them is -3. Multiply is 3. Yes! Holy simoleons. It worked. We found the one that worked. If you're wondering where this 0 came from, totally get it. We have to put in a 0 as a placeholder if there's any missing. It was to the 5th, to the 4th, to the 3rd, to the 2nd, and it didn't have any x to the 1s. So 0x to the 1s. Now, you've been taught everything. That's everything that can be tested on. But now you need to practice. And so we have all day tomorrow and all day the next day to get better and better. And you all know that if you do bomb Friday's test, there's a cumulative that'll be coming after that. But it's so much better to go into the cumulative with an A. Oh my gosh. You go into the cumulative with an A, you have nothing to worry about. All right, so let's see if we can get an A on this test the first time. All right, now if I had to actually write the factored answer, this would be x plus 1, and this part, this would be the x's, this would be the x squareds, this would be the x to the thirds, and this would be the x to the fourths. And if they made me factor it again, which one of your later problems does, if they made me factor it again, please pay attention to this, just listen. I've factored this, but you can also factor that, and you can do the same exact thing again. You can figure out the factors of the coefficient and the factors of the constant, and then you'd probably realize that it's a 3, and then 3 would go into this, and then you could factor it again. And you could keep factoring it like that forever. You keep on figuring out new things you could check, and I know, it sounds insane. That's how hard this class is. There's one question this hard. All right, I'd like to start number 4 with you just because I know it's kind of hard, and I think you'd be stuck on it at home, and I think if I get you past the hard part, then you'll be able to finish this assignment. So let's do 1, 2, skip a few, and please get to number 4. Mr. Dixon, that hand hasn't moved. I don't think you're on number 4 yet. All right. Isaac, could you read number 4?
The following polynomial has 2 real solutions and 2 imaginary solutions. Use any method to find all 4 solutions.
Hint, you're going to use FCON or FCO, and you're going to do synthetic division. Okay, keep going.
The equation is f of x equals x to the 4th third minus 16x minus 20.
All right, nice part about this, they didn't fool us with a missing term. We got an x to the fourth, a third, a second, and we got an x to the first. So we got all of them. So there's no missing terms in here. Now, the sucky part is I have to figure out all the things that could work. FCon, and FCO is kind of irrelevant in this case because it's a 1, and I'm going to divide by 1. I'm going to skip that. So it's just the factors of the constant, and it's plus or minus of those. And it could be negative 20 or positive 20. It could be 5, because 5 goes into 20. It could be 4, it could be 2, it could be 10, and it could be 1. That's insane. So we're going to divide it up. Divide and conquer, right? So I'm going to have different rows check different things, and eventually one row is going to be like, yeah, that one worked. Okay, so we're going to skip 20 because I don't think it's 20. I think it's a 5 or a 4 or a 10. But you guys, row 1, would you please check the 5? Okay? Row 2, would you please check negative 5? Row 3, would you please check 10? Row 4, would you please check negative 10? Wait a second, don't tell everybody. I want everybody to try this. Okay, hold that about a second. And would you guys check 2? This row, check 2. And would you guys check negative 2? One of those is gonna work. I know you guys do this when you help each other out doing your homework. You're like, you try this, I'll try this. I'm just doing that on a big scale here. All right, while they're checking that, what's your question that you had? So remember, this is the constant, right? And 5 is a factor of 20. 5 times 4 makes 20. It's all the things that are factors of 20. Did you find one?
Yeah.
Which one worked? 5? All right, 5 worked, everybody. So once you know one that works, you can just move on. Now, one pro tip. Sometimes, by accident, you try 5 and another row tried like 2, and they both work. Then you can pick either one. And after you factored it the first time with a 5, then it'll factor the second time with the other number that worked. So if you ever find 2 numbers that work, they will both work. They just do one of them at a time. So we know 5 works, and we get, drop it like it's hot, multiply, add, multiply, add, multiply, add, multiply. It worked, yay. And then here's my factored answer. But the problem is you're not done, because you have to factor it again. So the reason I'm bringing that up is if one of the other rows happen to figure out that, oh yeah, 2 actually works, well then now would be the time we can use that to factor this part. All right, did any row figure out another number that worked? All right, then, why do I know you can't just stop right here? Because it asks you for all the solutions. The only way you're going to get the solutions is if you can factor this thing further. So there must be some way to factor it. Now, I personally like divide and conquer. And when it has 4 terms, the odds are pretty good that you can do the divide and conquer way of factoring. But if you wanted to, you could go FCon over FCO again and go, what would work? Maybe 4 works, maybe 2 works, maybe 1 works, maybe plus or minus of all of those work. And you could do synthetic division. Okay, I know that was super intense. Thanks for paying attention. You just made it through, honestly, one of the hardest units of the entire year. And now you'll have some challenging problems to practice, and then the test will be Friday. And you'll get a second chance at the test on a cumulative coming up. So let's see if we can pull off A's on this test on Friday.